Hello guys, welcome to my channel. Today let's memorize this flashcards of biostatistics. So the first one says, in normal distribution, mode, mean and median are equal. Yeah, that's a common question in MBME forms I see all the time. And then there are three types of data distribution: the normal distribution, the positive skew and negative skew. So the normal distribution, everything is equal, the mode, the mean and median. And the positive skew, the mean is greater than median is greater than the mode. And then the left is skewed, or the negative skewed is the opposite of the right skewed. Okay, next, attrition bias. Attrition bias is mostly seen in random control trials when there are two groups of data set, two groups of people under investigation, and then one of the groups loses follow-up of some of the patients, and then that causes. So the next one is negative predictive value and positive predictive value. So this is just the formulas. Negative predictive value, true negatives of a true negatives plus false negatives. So it's all negative. Positive predictive value is the opposite. True positives of a true positives plus false positives. All positives. Next says odds ratio. Odds ratio is used in case controls. I used to confuse. I always thought odds ratio was cohort study, but it's the opposite. Cohort is a relative risk, and odds ratio is for case control studies. Receiver operator curve. Even me, I don't know this one. Okay, this is a curve. It is the sensitivity, to what do you call it, specificity. So it says the closer it is, the line is to the margin, that's 100% sensitive. That's when a test is, I think, good. I don't know. We have lead time bias and length time bias. This is my weakness. I always see this in AMBOS questions and I get confused. Lead time bias is when a disease is detected by a screening, and then the disease is mistaken that it has a long survival rate, but it's not. It's just because it was detected by a screening test. And the length time bias is a indolent disease, a disease that is not, it's not progressing so rapidly. It's detected by a screening test, and then now you think this is screening test is so sensitive, but it is not. There's a bias. Type 1 and type 2 error. Type 1 error, the alpha, this is rejecting the null hypothesis even though it is true. So it's also called the alpha. It depends on the data's clinical significance is dependent on the alpha. So the more alpha is low, the higher the significance of the study. Type 2 error is accepting a false null hypothesis. When it's accept a null hypothesis. Null hypothesis, that's false. You accept a false null hypothesis. So it's also called the beta, and the beta, the power of the study is dependent on the beta or the type 2 error. So if the type 2 error is low, the power of the study is high. Power is 1 minus beta or type 2 error. Everybody's weakness, clinic confidence interval. Confidence interval, I think it is mostly 95%, and it means by definition that if this test is repeated by another person, 95% it will yield the same results. So that's confidence interval. They say confidence interval should not cross 1. It should not cross 1. And if it crosses 1, B value becomes more than 0.05. So the B value should be always less than 0.05 so that your clinical study becomes significant. So confusing. Number needed to treat and number needed to harm. I don't know why this even exists. Number needed to treat, one of attributable risk, and number needed to hurt is same, I think, formula. So this one, I don't know why do we have to harm some people so that we can treat others? I don't know. A study is significant only if B value is less than 0.05. Correlation coefficient measures direction and strength of linear relation. So one thing important is correlations can be negative or positive, but correlation is not equal to causation. Like you can see there's positive correlation between smoking and lung cancer, but it does not mean that lung cancer is caused by smoking. So correlation is not causation. So that's just a fact that I have to remember. Positive likelihood ratio and negative likelihood ratio. So just this formula. So positive likelihood ratio, sensitivity of 1 minus specificity, and negative likelihood ratio is 1 minus sensitivity of a specificity. Validity and precision. I've seen this a lot. Validity is the results of a test is same as the gold standard. So that's valid result, yeah. But precision is, it means if these results are repeated, if this test is repeated, if I did that test and another person repeats, we get the same result. But it does not mean that result should be the gold standard, should be right or wrong. But if we repeat the same study or the same test, we get the same results. That is precision. And that's all for the cards.